Okay, look at the number 2 here. You measure a cubic container and find it to be about 10 centimeters, right? And then each side. From this, you conclude that it holds 1,000 cubic centimeters. However, your measurement is actually only within positive negative 0.1 centimeter. So you can be sure that the size must be in between this 9.9 or 10.1, right? What are X, Fx, and A? Based on this textbook, the story is this. You measure mathematically, you know the cube. Okay, hold on. This is the cube. This is a cube. So mathematically, you can draw a cube like this, and we know each side is 10 centimeters, right? 10 centimeters, all the sides equal. That's for the cube, right? Now, but the things that when you do the real measurement, depends on the instrument you're using. Maybe there is some error there, maybe longer or maybe shorter. The lowest, the size is what, 9.9, and the highest may be 1.1, no, 10.1. So from here, because the size changes the measurement, there's an error there. So the total volume will be changed, and there is an error on the volume. Okay, so right now the X, based on this book, we consider as a 10. That's the measurement you made, and this is the Fx will be what? Fx will be equals to volume, which is x cubed, because each side will consider as x, right? Because we don't know, because yes, it's 10, but maybe 10.01, maybe 10, less than 10, like 9.98, something like that, right? So that's why we put the function as this, is the volume. And then the problem here, the A here is considered as what? Considered as 0.1. That's positive or negative. It means more than 0.1 or less than 0.1. That's the range there, okay? So that's this part is easy. But they ask you use the tangent line approximation to estimate the error in your volume of 1,000 for the volume. Because of the size change, so the volume change, so there was an error on the volume. How do you do that? The first thing first is you do derivative first. F derivative equals what? 3x squared, right? Power root, yeah? And then from there, you can find out F10 derivative will be equals to what? Just 10 times inside 10 squared, that's a 3 times by 10 squared will be 100, that's a 300. That's this one, right? This derivative. And then we need to find out what? We need to find out the rate, right? The change rate. So there's a tangent line should be like this. So the real volume function will be what? Will be, because we know F10, that's our original, if its measurement is accurate, that will be 10 to the third power, right? That's because of this function, because of this function. So if you, x equals 10, 10 to the third power will be 1,000, right? So the volume right now, you can represent like this. Supposed to be 1,000, but at the x equals 10, the rate is this. Means this is slope of tangent line at the x equals 10, right? So that means 3,000. We're going to time by what? Time by x minus 10, like this. Means depends on real axis. If x equals like a 10.1, so you're going to be what? This one mentioned, you can get a 0.1. 0.1 times 330. That means 30 more volume because of this change, the error of your measurement of the size of the cubic, right? But if this one equals 0.99, 0.99, right? So on the 0.9, no, if this one equals to 9.9, right? That's the lowest you can go. If you go 9.9, this one minus 1 is 0.1. 0.1 is negative 30, right? Negative 30, so that means 900, 970. That's the volume range, okay? So right now they ask you use a tangent approximation error, the error. So this part is where the error from. So the error will be equals to 300 times by what? X minus 10. That's the error, okay? And because we know the error, we use the absolute value, minus 10 will be less than equals what? 0.1, right? Means either lower than 0.1 by the 10 or bigger than 0.1 from the 10. You got this one. So, find the error for this one. So this is the error already. But this is error for the volume. Error of the volume. This is error of the size. Okay? Now, let's continue. Go to the next part. We move on here. We move on a little bit for the C right now here, okay? Let's give the percent error of your imaginable length of the size. So we know that here, we know that this is the error of the size, right? So for this one, you can get a what? You can get like a positive or negative 0.1 out of the size. The actual size is 10, right? So that will be what? Positive and negative 1%. Because this one equals 0.01. That's positive and negative. Change the percent. That's just the answer for the C here. Okay? For the C. And then we can go to the, you have one more part of this question here, or D here, okay? So D said what? Give the percent of the error of estimate of the volume. So when you say percent error of the volume, what you need to do is you need to go by the error of the volume, right, over the volume. Okay? So error of the volume will be what? Error of the volume, we knew that will be here. This one, 300, right? So you have the positive or negative 300. Either more than from 1,000 cubic centimeter add by 300 volume in maximum, or minus 3,000, okay? So this is error will be positive, negative 300, and the volume is this. When you make the ratio, that will be the percent. So you can get what? Get like this one. So you can get like positive or negative 3 over 100. So this one you can get what? That's positive or negative 3%. So that's the volume of the estimated of the volume. Okay. So now let's recall what we did here for the whole thing here. Okay. From very beginning here, we measure the cube, and each side is supposed to be 10, but because of the instrument or the person measure it, they involve what? The error there. And then you're supposed to measure the x, so x is x, fx is x cubed, right? That's volume of the volume of the cube. And then when this one equals to 10 here, when the measurement exactly 10, that's 1,000, okay? And then derivative of when x equals 10, that means what? That's the rate of the error. When you time them, plug into here by 10, right? You get 300. So this is a rate. Based on that, we can get a tangent line. This is the one here. This is for the answer B here. tangent line approximately estimate the error in your volume of 1,000 for the volume. And then this is the accurate measurement, and this is the error, okay? The error of the volume will be, let's see here, we can see that here. Error of the volume will be this. That's just this part, okay? And then the error of the size will be this. This considered as what? Error of the size, each side, right? Okay. And then when you have this, so you can find out, like, give the percent of the error here. They said what? Give the percent of the, okay? So they give percent, they give what here, let me go down, okay? You can see here. They said give the percent of the error in your measurement of the length of the size. So you just, this 0.01, no, 0.1, that's here. You see, I put it here. This is 0.1. This is error in the measurement of the size divided by the length of the each size 10. So you change it, you can get this one now. And if you want to find the volume error, right, you should use what? Error of the volume divided by the volume. And then error of the volume is 300, positive or negative, divided by 1,000, that's this one. That's why you have what? 3%. But you may increase by 3%, maybe decrease by 10%. So that's a positive and negative. You got it? Okay. So the D, we answered this one. Estimate the volume of this already here. Because this is the percent of error of the volume. This is the percent of error of the size. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.